This next problem comes from section 3.3, the first derivative test. And given our function f of x, our instructions are to find the local extrema of f and the intervals on which f is increasing and or decreasing, and then to sketch the graph. So in order to determine where the graph is increasing and decreasing, we're going to look at the signs of the first derivative. So f prime of x, 3 times the 1/3 would be 1. X then would be squared. You get minus x minus 6. So we'll find the critical numbers, which is where the derivative equals 0. And our quadratic will factor to x minus 3 and x plus 2. Using our zero product property, we find the critical numbers are at 3 and -2. So from here, I am going to use a number line. You can also use a sign chart. And my critical numbers are -2 and 3. On the top here, I am going to indicate that this line is for what the characteristics are of f prime. And then down here, f of x. I know at -2 and 3, the first derivative is 0. If I were to substitute a number less than -2, so something like -4, this factor would be negative, this factor would be negative, the product would be positive. A number between -2 and 3, such as 0, I would have a negative times a positive, which would be negative. And then in this interval, a number substituted into the derivative would yield positive. So our conclusions here: when the first derivative is positive, the function is increasing. First derivative is negative, the function is decreasing. First derivative is positive, again, the function is increasing. Now, in terms of local or relative extrema, when the first derivative changes from positive to negative, we have a relative maximum. And when the first derivative changes from negative to positive, we have a relative or local minimum. And now to sketch our graph, we'll use a couple of key points here. We'll use our critical numbers, our relative mins and maxes. So at -2, f of -2 is 9 and 1/3. At 3, we have a function value of -11.5. And we know from looking at our function that our y-intercept would be 2, so another point to use on our graph. And so from -infinity to -2, our function is increasing. From -2 to 3, our function is decreasing. And then from 3 to infinity, our function is increasing. So in conclusion, f of x is increasing from -infinity to -2, and then from 3 to infinity. F of x is decreasing from -2 to 3. We have a relative max at x equals -2, and a relative or local minimum at x equals 3.